Click on the subscribe button and press the bell icon for watching more update videos. Thank you.
Assalamu alaikum friends, this is Sami and you are watching Civil Engineers YouTube channel. Dear friends, today my topic is too much important and many students they were asking about this topic, that how we can design column footing. Okay, so design of column footing, but this is the square column footing design, right? So if you need the article about this kind of article, new information, notes about civil engineering, so there are a lot of notes and a lot of article about civil engineering, and I update my website daily for civil engineers, so you are able to visit my website www.civilglobal.com. okay, so if you have any questions, so you can also comments there, so we will online every time there, so we will reply your answer. Okay, but remember, like this video and subscribe this channel, and just visit to our website www.civilglobal.com. if you need the article, so the link is in the description of this video, so visit and read your articles and get new information and latest information. Okay, let's start, but like this video and subscribe this channel for more update videos. So design of column footing. Okay, so this is a square column. So when you want to design the column, so how much steps are required for us to design a column? Okay, so let's come on. So design of column, required steps. The first one step we need to find out the area of footing. Okay, so this is a column and this is a footing. So what will be the area of footing? First step. Okay, and second one, we need the sile reaction. Okay, we need the sile reaction. Okay, to design a column footing. And the third one, we need factor moment. Okay, and factor moment, so this is a column, okay, and this is the footing, and we need the factor moment for the critical section for the bending moment, and this is need to find out the steel and design of steel. Okay, factor moment. And the last one, we need to find out the required depth, okay, for the column. Okay, so this is the column, this is the column, okay, and this is the footing, so this is the depth of the footing. Okay, what will be the depth of the footing? Okay, and design of column, so column footing depth is equal. So now this is the column, okay, and this is the what we can say footing, okay, and this one is a bearing capacity of sile. Okay, and the applied load on the column, okay, which is 2000 kilonewton, but this is the square footing. Okay, let's start. First of all, footing area. Second one, we need sile reaction. Third one, we need factor moment, and fourth one, column footing depth. But keep in your mind, this is the part first video, and part second video I will also show you how to design the steel and quantity of steel for this column. Okay, and the column size is 200 millimeter by 200 millimeter. So what will be the area of the footing, right? Okay, so given data we required here, so P, applied load which are coming on the column, that is 2000 kilonewton, so you are able to change it. Okay, so you can put anything here. So the size of column, I've already told you that the size of the column is here, which is 400 millimeter by 400 millimeter. Okay, and SBC, sile bearing capacity of, okay, sile bearing capacity, which is 150 kilonewton per meter square, and 150 kilonewton per meter square sile bearing capacity you are able to get from the lab test. Okay, so there are the many sile, and many sile has different strength or bearing capacity. Okay, so this is a column, this is a footing, and this is the bearing capacity. Okay, and this bearing capacity I have here 150 kilonewton per meter square. Okay, for the different type of sile we have a different bearing capacity. Okay, there is also my article in my website in civilglobal.com, and also I have a video in this channel. Okay, you are also able to read the article and to watch the video. Okay, and we will use to design the column, so we will use the M20 grade of concrete. Keep in your mind M20, okay, grade of concrete. So FC, this is the type of steel, okay, the iron steel grade, so which I will use here 415. Okay, so FCK, this is the compressive strength of the concrete, 20 Newton per mm square, because I am using here M20 grade of concrete. So 20 Newton per mm square is the compressive strength of concrete. Okay, and Fy is a yield stress, okay, or strength. Okay, so this is the 415 Newton per mm square for the FC, okay, for this grade of steel. So now come to start the and required test. The first one step, the first one area of footing. Okay, so the first one area of footing. So first of all, we have to increase the 10% above load. Okay, so this is the P, which is 2000 kilonewton. So we will increase 10%. Okay, so from 10% you can get the value. Okay, 10 divided by 100 and multiply with 2000, it will give you 2200 kilonewton. Okay, so this is the increase. So formula to find out the area of column, so area is equal 10% of P plus P divided by SBC. Okay, 10%, which is this one. Okay, and of P, so this is P. Okay, so it will give you 2200 plus P again, which one? This one, P. Okay, so from this you can get again P is this one. Yes, so area is equal, SBC is a soil bearing capacity. Okay, soil bearing capacity, which is 150. Okay, 150 kilonewton per meter square. Now here we have a yes. Okay, so now we have to find out the area of the column. So for that, area is equal to 0.1. 10% will become 0.1 of 2000 plus 2000. Okay, and divide by SBC. So SBC, we have here what? We have a SBC 150 kilonewton per meter square. So divide by 150 is equal to 2200 divided by 150 is equal 14.66 meter square will be the area of the column for the size of 400 mm by 400 mm when we applied the load 2000 kilonewton. Right, now the footing size area, okay, is equal area under root 12 14.66. so it will give the one side of the column. Okay, so this is a column footing. Okay, and it will give you the S, because this is square, so S is equal 4 meter. How? Because 14 divided by 14.66 under root, it will give you 3.28 meter. So say 4 meter. So one side is equal 4 meter and other side is equal 4 meter, and the area will be what? The area will be 14.66. so the one step is being clear. Now we need Seyle reaction. Okay, so Seyle reaction here. Yes, Seyle reaction. So for the Seyle reaction, we have a symbol QU. Okay, formula PU divided by area of the column. So here PU is equal P multiply 1.5. So this is the factor load for the column. Okay, PU means factor load of column. So P already we have a 2200 multiply 1.5. So it will give us 3300 kilonewton. Okay, this is the PU. Okay, now for the formula we use QU is equal PU divided by area. So PU already this one, and area we have a 14.66. okay, which is this one. Okay, area of column. Right, so from this you can get the Seyle reaction. Okay, which become 225.10 kilonewton per meter square. Okay, now we need the third one step, that is factor moment. So formula we can use MU is a symbol for the factor moment. Okay, so MU is equal to P means load, applied load, which is 2200. Okay, and multiply B, breadth of the, or S, breadth of the footing. Okay, multiply into L minus D. L is also same like breadth. Okay, and D is a depth or breadth of the column, and this one is also length of the footing. Okay, and divide by 2. And because this is, look at this, I will show you here. This is the factor moment. Okay, so for the factor moment we have to find out the one side. Okay, if this is this one or this one or this one. okay, and this is the column which is 400 by 400. Okay, so I have to find out the one, so it will is equal to all of side. Okay, so a critical section for bending moment. Okay, so for that we have to find out, so therefore we do it divide by 2, because one side and other side we have to find out the one side. Okay, so L minus D, so L is a length of the footing and D is a depth or the breadth of the column, which is 400 mm. Okay, and all square and divide by 2, 1 divide by 2, because this is a two side. Okay, therefore, so mu is equal P, we have the value of the phi 2200. Okay, this is the applied load, multiply 4 is the side of the column. Okay, B or B. Okay, and N to 4 L is already, if you say that this is L or this is L, again this is 4, and subtract D, so D is a, okay, the column depth we can say, or we can say length or the breadth. So I've taken just the 400 mm, so 400 mm will be changed to the meter, because we have to find out the factor moment in kilonewton. So therefore 0.40 we will divide it by what we can say, this is we have to change to meter. Okay, divide by 100, so it will give us meter, right? So sorry, 1000. Okay, so for that we have to find out now divide by 2 and all square divide by 1 divide by 2. It will give you 1720 kilonewton per meter, not per meter, because this is not the unit. Okay, so kilonewton meter. Okay, now we have to find out the required depth for this column footing. Okay, so look at this. So now we have to find out the depth of the column footing. Okay, what will be the depth? Area is already done, and now we require the depth. Okay, cell direction already done, factor moment has already done. Okay, now we have to find out the required depth. D formula we can use, D is equal to mu factor moment, right? And from factor moment divide by 0.138 is a constant for this depth, multiply FCK, and FCK is a 20 kilonewton per mm, 20 newton per mm square. Okay, so this is the strength of the compressive strength of the concrete, and multiply B. Okay, and what is B? B is already the breadth of or the length of the column footing. Okay, so from this you can say 17,820 is this one, 17,820, sorry, 820. I've written here 17,820. Yes, 17,820. Okay, 17,820 multiply 10 power 6. That's why I put, because I have to change it to Newton per mm square. So therefore we will multiply it with 10 power 6. Okay, multiply, divide by 0.138, this one, and FCK is a 20 Newton per mm square, multiply B is a 4000 mm. Okay, so it will give us the depth of the column footing, which is 401 mm. Okay, so now depth of the column will become what? 400, depth will come here, 400 D is equal 401 mm. Okay, so this is the depth for this column footing. Okay, so this is the important topic for today, and in next lecture I will show you how to design a steel, and percentage of the steel are required in this column footing. Okay, so you must visit to my website and like this video and subscribe this channel for more update videos. Thank you, all the best, bye.